that files lectures basically, which I started on last turn. Did you see that? Yes, I want response. I want response quickly. Did anybody see that? Hello? You have to respond, otherwise how can I understand? Subham? Are you there? Subham
Yes,
Kumar.
sir. Yes, sir, it is visible.
So you have to respond. You people have to respond. Otherwise, how can I understand whether you have read certain things or not? Did you revise that Taylor's expansion and other things? Anik Mandal, Lawrence, respond quickly. Quickly respond. Lawrence, are you there? Lawrence?
Yes, sir.
So why you are not telling?
Sir, my name is Leo. My second name is Lawrence.
Pardon me? Pardon me? Tell me again.
Sir, my name is Leo. Leo.
Leo. Okay.
Yeah.
Okay. So now you can tell why you are muting yourself. Did you revise that? Whether you were present in my last lecture?
Yes, sir.
So did you revise that Taylor's expansion and other things of numerical analysis?
No, sir.
Why? Anik Mandal? Anik Mandal?
Yes,
Anik
sir.
Mandal?
Yes, sir.
So you have to revise that, otherwise there will be trouble for you people. You won't be able to understand the things. And this whole course is basically based on the numerical. All the methods I will develop through this Taylor's expansion. You have to understand that, and you have to see that certain numerical part are used. So you have to do that. Anyway, I will just quickly review the things what I have done on the last turn. So basically, I will start from the beginning itself in one sense, you can say. But briefly, I cannot do all the things. So as it was discussed on that last turn itself, that for numerical, why we study numerical analysis, once we are not able to get the exact solution or the analytical solution, we go for the numerical solution, and then the very first thing what we have to do, for example, the domain of a problem, you have to subdivide into certain subdomains. For example, here if you see the on your screen, it is the interval is given from A to B. That line is there where A is given as x naught, A is taken as x naught. So I have divided this into domain A to B, that interval, into certain subdivisions, and that are basically x naught. The points are x naught, x1, x2, x3, and so on. The last point is xn, that is equal to b. We have that is the last point. And if we have these equal spacing, we say that they are equi-spaced subdivision, and these points x0, x1, x0 and xn are boundary points, but other points x1, x2, they are also x0 is also included if I say the mesh point. So x1, x2, x3 and all are called basically mesh points, nodal points, grid points. Several names are there. So it is written mesh point and grid points are written here. It does not matter whether they are equally spaced or not equally spaced. It does not matter. They will be called mesh point and grid point, nodal point, whatever you call it. If they are equally spaced, then the step size, the difference between x1 to x0, sorry, will be your b minus a divided by h. And we have even further discussed that your x0 will be your a, so x1 will be a plus h or x0 plus h, x2 will be either you say x1 plus h or you can say x0 plus 2h, or in general we can say that xk will be your kh. X0 plus kh, or k running from 1 onward, that is integers. Is that clear? Everybody should respond, please. Is that clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Once you say, then only I can move further. Na? Okay, these things I will come back again because you are facing, unless until you understand that Taylor expansion, it's a difficult job to explain. So if it is required today, I will do, otherwise I will go further. There is one definition that you have to understand. Yeah, here it is. We say that the one function fx is of capital O order. It is written O, capital O. There is a small o also. So that I am not going to discuss here. That is not required for this course. So I am not telling that. Of capital O gx order, another function order, means if either you say that magnitude of fx by gx is less than or equal to m for some m, obviously m will be greater than 0, obviously, because it's a magnitude, so this has to be greater than 0. So if this happens, we say this is of capital order gx, f will be of capital order gx, right? We'll use this fact, the capital order term. Now I will go directly to the Euler's method first. So we have a differential equation y prime equal to fxy. I have already told that this is a non-linear differential equation, and when we say that y prime equal to fxy is a non-linear differential equation, if your fxy is a non-linear function in y. What is the meaning of non-linear function in y? It is not a linear function in y, meaning by that fxy, we if fxy we can write as gx plus hx into y, then we say that it is a linear function in y, otherwise it will be a non-linear function in y. Is this clear to everybody? Is this clear to everybody?
Yes, sir.
Okay, good.
Yes, sir.
So now next thing, what is that your yj you write down the, now at least you, since we have already discussed certain things, you write down the whether you have the your register and your calculator and pen with you or not. Yes.
Yes, sir.
If you don't have, quickly take that. Quickly take that. Those who doesn't have, the quickly take that. Quickly take that. Quickly take that. I'm just waiting for a few seconds. Have you taken that? Everybody has that register and pen and calculator, all the things. Yes?
Yes, sir.
Yes,
Most
sir.
of everybody should have. Everybody has. So now I'm moving further. Write down the Taylor expansion for y of x. For example, here it is you see, you have subdivided the interval into your 0 to 1, 0 a to b into your, here it is x0, so you may write x0 to let us say b in n number of subdivisions. The nodal points are x1, x2, x3, x0 is included there. x0, x1, x2, x3, that I have shown in the very first slide. Shall I go back? here. So the x naught to b, I have subdivided into n number of subdivisions. These are equispaced, let us say. So h will be your b minus a by n. Write down. H will be your b minus a by n. Have you written that?
Yes, sir.
Have you written that? Yes.
Yes, sir.
Okay. Now write down y of x j plus h. Write down x y of x j plus h. What is this? Xj plus h is what? Xj plus h is your xj plus 1. Yes or no?
Yes, sir.
I want other than you also the answer. Other people should answer quickly. Yes or no?
Yes, sir.
Yes, sir.
Now wait. Now I will use one notation here. Otherwise, every time we have to write this y of xj plus h and so on and so forth. I will use yj plus 1. You see, after equation 1, it is written on the left hand side yj plus 1. Is that clear? So write down the notation for this is used as y of xj plus h as y of y subscript j plus 1. Is that clear? Is that clear?
Yes, sir.
Okay. Some more notations I am
Yes,
telling.
sir.
Write down. I will explain further certain things. Write down f of xj, y of xj, fxy is also there. So f of xj, y of xj, we write as just simply fj. We write just as fj. Keeping in mind, it is your f of xj, y of xj. Is that clear? Is that clear?
Yes, sir.
Okay.
Yes, sir.
So you see, you have subdivided the sketch this interval and its subdivision, which I have done here. X naught to b. So subdivide into n number of subdivisions. So just make this figure. This is straight line. Subdivide. Write down these points x1, x2, x3. Write down x1 equal to x naught plus h. H you write down h equal to b minus a by small n. So x naught is x1 is x naught plus h. X2 is your x naught plus 2h and so on. Write down xk equal to x naught plus kh. Whether everybody is able to hear? Whether everybody
Yes,
is
sir.
Yes, sir.
Yes, sir.
okay, good. These are the certain notations which you will follow throughout this course. Which will follow throughout this course. Right? Have you drawn this figure? Simple straight line.
Yes, sir.
Good. Good. Otherwise, every time I have to come back here. Now, for this general point x case, since the differential equation is valid for your 8x naught to b, so in particular, it is valid at the point xk also. So we may say that y prime xk equals, write down, y prime xk equals f of xk y of xk. Y is a function of x. So y of xk with your y of x naught, which is the condition given as y naught. Y of x naught given as y naught. Is that clear? Is that clear?
Yes, sir. sir.
Okay, good. Rather you write j because we have used here j. So x of y prime of xj equal to y of fxj and comma y of xj. It's just suffix. It's just a dummy one, right? Now you write down the Taylor expansion for y of xj plus h, which you in notation write as y of j plus 1. Anybody can tell me what will be the Taylor expansion? This is a simple one. Anybody? Leo? Anybody? That you can tell. You have told on the last turn itself.
So please repeat the question.
You just tell me, write down. First you write down on your register. It is written on the slide, don't worry. Write down on your register y of xj plus h. Have you written?
Yes, sir.
Write down its Taylor expansion.
Y
It will be y of xj. Yeah, that I will write later on. Y of xj plus h,
H
y
into
prime, y
xj.
prime xj, right? And then
Yes,
plus
sir.
h
Square
square by 2 factorial, y
Y
double
double
prime. I will truncate
xj.
here itself. Y double prime xi, where xi will lie between xj to xj plus 1. Is that right? Is that right?
Yes, sir.
Okay. Then you can rewrite this as yj plus 1 in that notation equals yj plus h y prime j plus h square by 2 factorial y double prime xi. Is that clear? Is that clear?
Yes, sir. Yes, sir.
Okay. Now I will come back to this slide.
Yes, sir.
I will come back to this slide. You see, I have written here yj plus 1 equal to yj plus h yj prime plus h square by 2 factorial y double prime xi. So where xi lies between xj to xj plus 1. Same thing is written. Same thing is written.
Yes, sir.
Okay. But y prime j, you see your register, you have written y prime xj equal to what? F of xj, y of xj. Right?
Yes, sir.
So you replace that here. So yj plus 1 equal to yj plus h times f of xj, y of xj. I am writing in full. Plus I am writing t of h. Here, if you see this term, is your t of h. T of h means I am treating this as a function of h. Is that right? So this term will be your t of h. Now, if we, why the word truncation came, I will, before telling that, I will just explain that if we ignore this, means, if we ignore this means what? Means your yj plus 1 can be approximated as yj plus hyj prime with this much order of error, this much of the error. Is that right? Is that right? Yes or no?
Yes, sir.
Okay. So let us first ignore this. Let us first ignore
Yes,
this.
sir.
Then what we'll get? We'll get yj plus 1 equal to yj plus hyj prime. This is your Euler method. This is called your Euler method. Yj plus 1 equal to yj plus hyj prime. Right? Now, here you have truncated your Taylor series at h square. Is that right? Here you have truncated. After that, you haven't taken any series term, means you have truncated at this point, right? So this is called the local truncation error. If we write that yj plus 1 equal to yj plus hf of xj yj, then this much of the error we are going to commit. And this is since we have truncated this series here, so that's the reason we say it is local. Why the local what, that I will tell you later on. It will come after some time once we tell the basic of these things, the analysis of all these things. That time we will understand. So this is called the local truncation error. Is this clear to everybody up to this? Up to
Yes,
this,
sir.
it is clear to everybody? Yes?
Yes, sir.
Okay. Now you rewrite yj plus 1 in your register equal to yj plus h f of j, either you write or you write full one, f of xj, and then y of j. Now you replace xj by y of j, right? Now put j equal to 0. So this will be what? Anybody tell me? Put j equal to 0.
y1 equals y0 plus hy0 dash.
That's right. So y0 plus h y0 dash, either you write or you write f0 or you write your f of x0 y0. Is that clear? Is that clear?
Yes. Yes, sir. Yes, sir.
Okay. What is y0? If you see the differential equation, y of x0 is given as y0. At the point x0, the point will be your y0. So that point is given. So means you can find out y1 by putting the value of y0 and f of x0, you know, right? Suppose it is the interval is 0 to 1, so x0 is 0 and y0 is also given. So this function f is known at this point, x0, y0. So everything is known on the right hand side. Is this clear? Is this clear?
Yes,
Yes,
sir.
sir.
Okay, so before I proceed further, let me explain this through one example so that at least this portion will be clear to you. Okay. So maybe I have to use another slide before I proceed. So just wait for a moment. First, I am taking a very simple example, and then I will move for the non-linear case. I am taking a very simple linear case so that you can calculate by even hand also, right? Write down this problem, write down on your register, because every time otherwise I have to show it. The slide is visible to you? Slide is visible to you?
Yes, sir.
Yes,
Okay,
sir.
so note down this problem, y prime equal to t plus y, y0 is 1, domain is given as 0 to 1. So solve this differential equation by Euler's method with step size is also required, h equal to 0.1. Have you written that? Everybody has written this problem? Shall I move?
Yes, sir.
Okay. So y0 is what here? Y0 is 1. Here it is given y0 is y at the point x0 is 1. So it is 1. Y0 is 1. X0 will be 0. You have to subdivide this interval 0 to 1. 0 to 1. So basically h is given, so x naught is your 0, and then x1 will be what? 0.1, x2 will be 0.2, x3 will be 0.3, and like that. Right? Is this clear? Is this clear?
Yes, sir.
Yes, sir.
So at the point x1, the first step will be at the point. So this is your x1 is your 0.1. So at the point x1, the solution will be your y1. That is y at the point 0.1 will be your y1. This value will be what? Y naught plus h means 0.1 into y naught is also 1. So write 1 plus 0.1, 0.1 into f at the point T naught, Y naught. Here it is T is written. So what is T naught? T naught is 0. So and F is given as T plus Y. F is given as T plus Y. T is 0. So it is 0 plus Y. Y naught is given as 1. So it will be 1. So what will be the? So you see here it is. The next step it is given. So y1 is y.1. This is your y naught plus h times f at the point 0, that is your x naught, into y naught, comma y naught equals, since f is your just t plus y, so it is 1 plus 0.1, and then into 1 because t plus y, t is 0, and then y is your 1, so it comes only 1. So the next value will be 1.1. Is that clear? Is that clear? This step is clear to everybody?
Yes, sir.
Okay. Yes. Any query? Any
No,
query?
sir.
Okay. Then you find out y2. Y2 is also written here. It is your y1 plus h times f at the point t1 into y1. T1 is what? T1 is your 0.1. Y1 is, you have already evaluated, that is your 1.1. So f of t1 y1 will be t1 plus y1. T1 is your 1 plus 1.1. So this is 0.1. T1 is 0.1 and y1 is 1.1. So here it is written. So this is your 1.2 multiplied by 0.1. So 1.1, that is your y1. So everything, it comes out to be 1.22. Is that clear? This you can calculate by hand, don't require any calculator. Right? Can you calculate y3? So you calculate y3 quickly and tell me what is the value. Quickly calculate y3. Quickly calculate y3. And tell me the value. 1.362. Others? Others? Quickly. This is just simple calculation you can do by left hand. You don't require even right hand.
Sir, 1.362.
Everybody is getting that?
Yes, sir. 1.36.
Yes, sir, 1.36.
Okay. Anybody has any query? I have explained very slowly everything. Anybody has any query? If you don't have, then I will move further. You don't have any query up to this? Okay, you calculate at
Sir,
least.
how T is calculated?
Excuse me, sir.
One by one. Tell me.
Okay, sir, my problem was that if the problem is complicated, then there might be chances that we miss some value or by mistaken we took some other value. So
By
in this
mistake, if you
numerical,
do anything, it is your fault. Nobody can help you. First thing.
no, actually this process is iterative, right?
Exactly.
So in this process, I know that if I missed one value, then it will be my fault. But can it be recovered that the same solution?
How will you get that? Tell me. You see, on the right hand side, if you want to left hand side, yj plus 1 is there, right? If you want to calculate yj plus 1, unless until you have just previous value, you cannot calculate yj plus 1.
Sir, actually, while solving this problem, I mistakenly took the value of y2 as 1.12,
So
which is
that you see that nobody can help you.
uh,
Because
and
it
it
is
is
human.
closer to the actually it is closer to the value 1.1
No. The
y1.
point is that no. If a problem is quite sensitive, so if you just miss even 0.001, if you do the mistake, means suppose it is 1.132 and you have written 1.123,
Yes.
it may give entirely different result.
Okay.
I can give you one example. Do you have access to the advanced engineering maths by Krzik?
No.
You can see that since you people are not here. So anyway, you just try to find somewhere. You have studied this system of linear algebraic equations. You have studied the system of
Yes.
algebraic equations, and then you know that Gauss serial method, Jacobi method,
Yes.
right? In the beginning of that chapter in the Krzik book itself, there are two examples, one or two examples. There are 3-4 examples, right? One example is just for that, a very simple algebraic two equations in two unknowns, and just a minor change was there, just like I have said that 1.01 and then changed to 1.99 or something of that kind. The solution of that two equations in two unknowns goes entirely in a different way.
Okay.
Right? So you just read that book. Iyengar, I don't know whether he has. That's the reason that Krzik book, even though that Iyengar book has more problems, a set of problems, but as a textbook, if you see, the Krzik is better.
Okay.
There are several such discussions are there. Okay.
Okay.
So if you do a little mistake, the whole thing goes in a different direction, right? So at least you calculate, all of you should calculate the next value y4, so that you should be confident enough that you can calculate that and tell me the value. Calculate that quickly, y4. So Girish, don't do the mistake now, this time.
1.5282.
528 and
Yes, sir. 1.5282.
5282, right? So others, yes, tell me. Yes, tell me quickly. Pardon me.
So it's 1.5282.
1.5282.
Good, very good. So anybody has any trouble in calculating up to that y4? Anybody? If you have trouble, without any hesitation, you just tell me, I will explain it. Anybody has?
Sir, I think
Okay.
I just missed one conceptual thing.
Go on, tell me.
So we are taking y dash equals to f of xy.
Y dash equal to, no, we are not taking. This is the differential equation given.
Acha,
Rastogi.
okay. Yes, sir.
You see that?
Yes, sir.
You are solving
But
that problem. You are solving that problem, no? Y prime equal to fxy.
yes, sir. But sometimes it's not separable.
No, I'm not. This example I have given just being the first example. Otherwise, you won't get the linear case in the general life problem, right?
Okay, sir.
So I'm moving to little complicated one. It is a non-linear case. Write down the problem. Next problem. Y prime. I will use this problem repeatedly. The reason behind that, so that you can compare the different methods. So write down the second problem, which is you are able to see on the screen. You write it completely. You add this Euler method also in this. It is written that solve the initial value problem. This u prime equal to minus 2x u square, u0 equal to 1, using the midpoint. So before that, you write down using Euler method, midpoint method, with h equal to 0.2 over the interval 0, 1. So basically, just write down this problem. Others I will tell you further. So instead, rather don't write this problem completely. Write down this problem u prime equal to minus 2x u square with the initial condition given as u0 equal to 1. Everybody has written?
Yes, sir.
Okay. Now, will this one non-linear problem or not?
Yes, sir. It
Is
is
this a non-linear
non-linear.
problem?
Yes, sir.
Why?
It is
Why it is
non-linear.
non-linear? Why
U
it is
square
non-linear?
term is coming. U to the
U
power
square
2.
term. U to power 2 is there, so it is a non-linear. So the differential equation is a non-linear differential equation. Is that right? Is that right?
Yes, sir.
Okay.
Sir,
Now, yes, ask me.
but linear equation, since there is only one, there is only one, that's like du by dx. It's not to the second order, or
U by dx means what?
sir, I'm asking ki, it is a single order differential equation, right?
First order.
Single order first order, right?
It is
So-
not the single order is called. It is the first order called. First order, second order, third order, like that. Because
Sir,
of
so-
U.
Sir, he is saying what will happen if higher order derivatives come inside this
Yes,
equation.
sir.
Oh, that will tell you later on. Don't complicate at this stage. First you understand the simplest thing, right?
Okay, sir.
You will
Okay, sir.
complicate more and more and more. Don't worry. You have read one thing. Let me explain that. You have read one thing, that in your system of differential equations. Or differential equation was there in your maths 1, maths 2 somewhere? Means
Yes, sir.
the
It was
two
there.
differential equation together?
Yes, sir. It was there.
It was there.
Ordinary
Right.
differential
So,
equation.
right. You must have seen how a second order differential equation can be converted into two first order differential equations.
Yes, sir. Yes, sir. By factorizing.
So
Yes, sir.
any order differential equation can be converted into system of first order differential equation. Does not matter whether it is second order, third order, it may be nth order.
Acha, okay, sir.
Now you got it?
Yes,
So
sir.
basically that's the reason this first order is studied first, so that you can see the other things through that. At least you can write in vector form, that is if you don't write down in coupled equations. The differential equation means one equation, the differential equation of first order, second order, second differential equation of first order, and like that, depending on if it is the nth order differential equation. So such you will get n number of such differential first order differential equations, right?
Okay, sir. Okay, sir.
Right? So that's the reason the first order is there. Other things will complicate, don't worry. First you understand
sir.
the very simple thing, right? So
Right,
apply
sir.
Euler method on this problem. Apply Euler method on this problem. So shall I leave this as an exercise? I want answer from you people. Hello?
Okay, sir.
So please explain this.
Okay, do it here. Do it here then. So u prime equal to minus 2x u square, right? I'm explaining now. U0 is given as 1. Interval is given as 0, 1. Means x is in 0, 1. So and h is also given. H is given as 0.2. So sorry, x naught will be what? 0. X1 will be what? I want answer from you people.
0.2.
0.2. X2 will be?
0.4.
So draw a line the way in the very beginning you have seen. Draw a line. X naught you write that 0 and 1. The one end is 0, another one is end. So x1 you write 0.2, x2 you write 0.4, x3 you write 0.5, and so on. Up to that, what will be 1? 1.0 will be, in terms of x, it will be
X5.
X5.
so it is 0.2. So 0.4, after that 0.6. X3 is 0.6, x4 is 0.8, and x5 is your 1.0. Is that right? Is that right?
Yes, sir.
Okay. Now, what is your Euler method? Uj plus 1 equal to uj plus h uj prime. Right? Uj prime is what? You can put the value here. Uj prime will be minus 2xj uj square. Right? So this can be written as finally uj plus 1 equal to uj minus 2h xj uj square. Got it? Everybody got this?
Yes, sir.
Okay. So now you can start. Now your iterative method is ready. So u naught is given as 1 because u0 is given as 1. So u naught is your 1. So u1 will be what? U naught, that is 1, minus 2 into h is 0.2. X naught is 0. So everything goes 0. Whatever the term is there, anyway, let me write. U0 square is your 1 square. That is 1. So u1 equal to 1. Is that right? Is that right?
Yes, sir.
Okay. So what will be u2? Now you can calculate u2.
0.6.
0.84.
Whatever is that.
So 0.96.
0.96. Okay, let me just wait for a moment. I'm doing something. Okay. You write down what is the exact solution of this problem. Write down this exact solution of this problem. Ux, there is the reason why I am telling you. Ux equal to, write down, exact solution of this problem is Ux equal to 1 upon 1 plus x square, means 1 upon inside the bracket 1 plus x square. Have you written that? Have you written that?
Yes, sir.
You differentiate this u prime. U prime, you just find out u prime. Ux is 1 upon 1 plus x square. So what is u prime? What is u prime? Just to
minus
online
2x
tell me.
upon 1 plus x square का whole square.
1 plus x square ka whole square. Right? And u is what? 1 upon 1 plus x square. You have started with u equal to 1 upon 1 plus x square.
Yes, sir.
So you can write u prime as minus 2x u square or not?
Yes, sir.
Right? And what is u0? Put x equal to 0, it is 1. u0 is 1. Yes or no?
Yes, sir.
Yes,
It is
sir.
given.
Right? So what is the exact solution of this? Ux equal to 1 upon 1 plus x square of this differential initial value problem. Is that right? Is that right?
Yes, sir.
So whenever you do apply any method, you have the exact solution, you can compare with the exact solution value. You can find out the value once you know that ux equal to 1 upon 1 plus x square at any point. Let us say, for example, here x3 is 0.6. So u at 0.6 will be 1 upon 1 plus 0.6 square. Calculate this value. Your approximate value at this point should be close to this value. Is that right? Is that right? Is that right?
Yes, sir.
Another thing, now you need not to ask anybody for any problem. You can generate as many as problems you wish. Take a function, differentiate that, try to write down in this form, and then your problem is ready. Is that clear? Is that clear?
Yes, sir.
Can you generate as many as problems? Right? This is a ux. You take any function, right? And then differentiate that. Rewrite in that form u form, and then your differential equation is ready. You put the value at x equal to 0 or x equal to 1, whatever the initial point you take. It is not necessary to take 0 every time. Right? Is this clear now? Is this clear
Yes, sir.
now?
Yes.
So now you will be self dependent. You need not to ask anybody or anybody that what will be the next problem. So this Euler method is clear to everybody? Euler method is clear to everybody?
Yes, sir.
Okay, good. Now another thing comes in the picture, that if we, for example, suppose here how many subdivisions you have? One, I mean it is at x5, you have got the value. Means 5 number of subdivisions you have. Right? 5 number of, suppose you take h as 0.1 only. Right? So there will be how many subdivisions? 10 number of subdivisions? Yes or no?
Yes, sir.
Okay. So it means what? This, you have taken the finite subdivision. You have taken the finite subdivision. Right? So the value should be better in your finite subdivisions. Right? You have
Yes,
seen the sentence in your maths on maths 2, as h approaches to 0. You have seen or not? In your limit. Hello?
Yes,
Yes, sir.
You have seen in your limit h approaches to 0.
Yes, sir.
Okay. But numerically you cannot go to 0. How will you go to 0? You cannot go to 0. So meaning by, if the subdivision is finer and finer, there also you take h is very small, meaning by that if h is very small, right? Here also, if the subdivision is finer and finer, then the results will be better and better. This you can experience by choosing your h finer and finer. For example, suppose you take h as 0.5, then you take h as 0.2, which you have done. Next, you can take h as 0.1. You may even further go 0.05 and then see the difference. You can table the solution, see the difference in the solution. You will find that in most of the cases, as you go for finer and finer subdivisions, you find the results better and better, right? Is this clear to everybody? Is
Yes,
this
sir.
clear to
Yes, sir.
everybody now?
Yes, sir.
Okay, good. So now I will move further. So I will close this this problem, this second one, which I have told to you, that u prime equal to minus 2x u square. Now you know its exact solution also. Whenever you calculate the numerical value through any method, you can compare that with the methods, and further you can, once you know more and more methods, then you can see that which method is better and why it is better. You can understand those things, right? Now I will close this slide and then I will go for another one. The first one which I have told earlier, I will go back there. You have to wait a minute because it is loading. Now can you see the slide?
Yes, sir.
Okay, good. So there are certain more things which I have to explain for that, certain notational things. You see how we have got the Euler method. We have ignored this error part, th, right? If this th is there, means yj plus 1 equal to yj plus h times fxj, y of xj plus th, then this y of xj will be your continuous solution, is known as, called as continuous solution. Once you ignore this local truncation error, meaning by whatever the things you are getting, that will provide you the numerical approximation to the solution at that particular point. Means at xj, yj will be that. At xj, yj will be that value. So if local truncation error is included in that, that will provide you the continuous solution. Otherwise, it will provide, actually it should have been written, since in your book it is written this way. So I am following the same notation. Otherwise, for continuous solution, normally it is written as y of xj for yj instead of yj, and f of xj, y of xj. Completely it is written. If you see the good books, for example, Atkinson and other books, you will find this type of notation. But in the Iyengar book, it is written like this. This is another Iyengar book, not that your first year Iyengar book. I will tell the whole thing. You can find on in the syllabus also on the net. So it is the numerical solutions of differential equations by SRK Iyengar. So, so this is the thing. This is the difference between if we write without local truncation error and with local truncation error. Now next we proceed. You see yj plus 1 or y of xj minus h. Yj minus 1 is what? Y of xj minus h. So what will be its Taylor expansion? It will be your yj minus hyj prime plus h square by 2 factorial y double prime. Let us say xi1, where xi1 will lie between xj minus 1 to xj. Is this clear? Is this clear to everybody?
Yes, sir.
Yes.
Okay. So we just rewrite it. We take this yj on the other side, yj minus 1 on the other side. So yj will be your yj minus 1 plus hy prime j minus h square by 2 factorial. Oh, there is one more thing. Okay, let me explain this and then I will tell that also. H square by 2 y double prime xi1. I will just replace this indices j by j plus 1 because you have seen in the previous method we have written yj plus 1 equal to yj. You can work with this also, but normal convention is yj plus 1 is written in terms of yj and others. So let us move from j to j plus 1. So this will be your j plus 1, then this will be j, this will be y prime j, so it will be j plus 1 minus h square by 2 or 2 factorial, it is basically 2 factorial, y double prime xi1. So instead of xi1, I have written xi2 because the indices is changed. So this will lie between xj to xj plus 1. So basically this we have got yj plus 1 equal to yj plus h yj yj plus 1 prime minus h square by 2 y double prime. This quantity is your truncation error. So we may write th as minus of h square by 2 factorial y double prime xi, and if we ignore this, we get another method to calculate the numerical solution of such type of initial value problems, that is y prime equal to fxy. So if we ignore that local truncation error, sorry. So you see here it is local th is there. We ignore this. We get that yj plus 1 equal to yj plus h times of f of xj plus 1 yj plus 1. Right? Now you see the difference. On the right hand side it is yj plus f of xj plus 1 yj plus 1. Xj plus 1 is always known, there is no trouble. But it is the equation in yj plus 1. Yj plus 1 you have to calculate, and on the left hand side also yj plus 1. So what type of equations these type of equations are called? Anybody? It is called implicit equation. You cannot calculate exactly directly by that. The way you have seen the Euler's method is your yj plus 1 equal to yj plus h of f of xj yj. Everything was known on the left hand side. Here yj plus 1 is given in terms of yj plus 1, and that too it is a non-linear one. So such type of equations are called implicit equations, while the Euler method is called explicit. Is that clear? Is that clear, everybody? To everybody, I will show these definitions once I will explain only definitions. Is this clear to everybody?
Yes, sir.
Now, now the next thing comes. This is an implicit equation, and that too non-linear equation. How will you solve this? How will you solve this? Can anybody tell me the way? Anybody?
Using Newton-Raphson method.
Exactly, 100% correct. Exactly. So how will you write f? So it is a function of yj plus 1. So we'll write f of, let us write capital F of yj plus 1. Capital F of only yj plus 1 equals your yj plus 1 minus, you just write down from this equation, that equation double star, that is yj plus 1 minus yj minus h of xj plus 1 and yj plus 1. This will be your the function f yj plus 1 equal to 0, for which you have to find out the value of yj plus 1. What I have written g, does not matter. So you write g of yj plus 1 equal to yj plus 1 minus yj minus h of f of xj plus 1 yj plus 1. And then we have to apply Newton-Raphson method. And if we see the Newton-Raphson method, it will be yj plus 1 n plus 1 superscript. We will tell that this is the iterations, n plus 1th iteration equals, just like you write that what is your Newton-Raphson method? Xn plus 1 equal to xn minus fxn by f prime xn, right? F prime is with respect to x because it was a function of x. Here it's a function of yj plus 1. So we have to differentiate with respect to yj plus 1. So this g prime, meaning by that it is your del g by del yj plus 1, right? Is that clear to everybody? Is that clear to everybody? Yes.
sir.
Yes.
Okay. And then as soon as Newton-Raphson method comes in the picture, you require the initial guess. You require the initial guess. Because first value you require y, for example, for j equal to 0, you are calculating. So it will be your y1 n plus 1 equals y1 n minus g of y1 n divided by g prime, means del g by del y1 prime, y1 n. So this should be there, right? So this I will explain separately because this requires full one lecture. This requires full one lecture how to, I mean, I will take up one numerical example. I will explain the whole thing, right? Is this clear? This second method, this is called backward Euler method. This is called the backward Euler method because we have used the backward formula. That is your yj plus 1, yj minus 1 equal to yj minus h yj prime plus h square by 2 factorial y double prime psi 1. That's the reason it is called the backward Euler method. It is called the backward Euler method. So up to this it is clear? Up to this it is clear to everybody?
Yes, sir.
Hello?
Yes, sir.
Do you want a break of 1 or 2 minutes? Or shall I continue? It was very simple. I think I can continue. Yes. I have gone very slow also. Shall I continue?
Yes, sir.
Oh, okay, good. Very good. Because nothing is taught till now. Very few things are taught. Okay, next thing. This I have told on the last run also. I have written the Taylor expansion for yj plus 1. You see on the left hand, right hand side. Sorry, it has gone up. Okay, so here it is yj plus 1 equal to yj plus hyj prime plus h square by your 2 factorial yj double prime. I have truncated at the next stage, that is your h cube by 3 factorial y triple prime psi. Then yj minus 1 I am writing is your yj minus h yj prime plus h square by 2 factorial yj double prime minus h cube by 3 factorial y y triple prime. I have written xi here. So here xi, I have already explained on the last one that using the mean value theorem, we can write if h is very, very small, keeping in mind, if h is very, very small, then xi1 and xi2 we can write combinedly as xi, where xi will lie between, I want answer from you people, xj minus 1 to xj plus 1. Is that right? Is that right?
Yes, sir.
Okay. Now subtract these two, means it will be minus plus, because here it is minus plus. Subtract these two. What you get? Yj plus 1 minus yj minus 1 equals, this gets cancelled out. So you get 2hyj prime plus 2 times h cube by 3 factorial is 6, y triple prime xi. We may write this as h cube by 3 because 2 times it is there. So we get that yj plus 1 equal to yj minus 1 plus 2hfxj yj plus h cube by 3 factorial y triple prime xi. Right? Is that right?
Yes,
Is that
sir.
right?
Yes.
Now we take this as th. So th is your h cube by 3 y triple prime xi, right? So if we ignore this local truncation error, we get the method as yj plus 1 equal to yj minus 1 plus 2hf of xj yj, right? And this method with the local truncation error, this one, that h cube by 3 y triple prime xi, this much of the error we are committing at every stage. This method is called the midpoint method. This method is called the midpoint method, right? Now, you just try to observe here. You write the equation for j equal to 0. Everybody, just write the equation for j equal to 0. It will be what? Anybody can tell me? This method will be, for j equal to 0 will be,
The negative one आ जाएगा.
Y
so
minus
that
1
that is beyond your domain.
Yes.
You have to start with x naught. Why not, rather I say, right? Y minus 1 is not known to you. It is beyond your domain. So you cannot start with j equal to 0. So this you have to calculate somehow using some other method. So let us start with j equal to 1. So what will be that? Y2 will be y1 plus 2h f x naught y naught. Sorry, this will be
Y2 is equals to Y0.
y no wait, y2 equal to y 2 minus no, j equal to 1, so it is 0 plus 2 your h f and then x1 y1, right? So it is y2 equal to y0 plus 2h f of x1. I think it may be here. Yeah. Right? Y1 you have to, now you require, if you see the right hand side of this, you require two values, y1 and y0. You require two values. Y0 is given to you because the initial value problem is given. Y1 you have to calculate, without that you cannot proceed further. So y1 you have to calculate using some other method. At this moment, since you don't know any other method, so at least Euler method is there. You can calculate y1 by Euler method, and then you can proceed the process of this midpoint method. Is that right? Is that right?
Yes, sir.
So, but if we have to use the Euler method in between the backward method, so that what is the use of backward method?
Wait. But this is not the backward method. Backward method, I have to explain separately, then you will understand. Because that is an implicit equation. You cannot calculate this directly. Right? You have to, for each value, you have to use your Newton-Raphson method
Sorry,
till you
midpoint
reach
method.
the. Pardon me.
Sorry, it is the midpoint method, right?
So no, midpoint method use is there. I will tell you why. What is the local truncation here? It is
H cube
that is
by
the next point I will explain.
Okay,
H
sir.
cube by 3.
3 factorial.
No, it is 3 now. It was 2 times H cube by 3. H cube by 3 factorial. Right? So
Error
it has
will be less.
the 2 gets cancelled out. So basically H cube by 3. White triple prime psi. Right? Now, I will go back to your Euler method. Euler method you have. What is the local truncation? H square by 2. Y double prime psi. Right? Is that right?
Yes, sir.
Is that right?
Yes, sir.
Okay. Now, I have written in that T of H as a function of H. So, if your Y double prime is bounded and Y triple prime is also bounded, Y double prime is bounded, Y triple prime is bounded, then this TH is called capital order H square for Euler method. This is called, I have given the definition of capital order H square. The function fx is called capital order G x if magnitude of fx by gx is less than or equal to m. Right? So this th is of capital order H square. If you see th divided by H square, what will you get? Y double prime by 2. Since Y double prime is bounded, so Y double prime by 2 is also bounded. Right? So you get that TH will be of capital order H square. Is this clear to everybody? Is this clear to everybody?
Yes.
I want to answer. Is this clear to everybody?
Yes, sir.
Okay.
Yes, sir.
Now you go to the midpoint method. Midpoint method, the local truncation error is H cube by 3y triple prime. Is that right? H cube by 3y triple prime. So what will be the order of local truncation error? If y triple prime is bounded, what will be the order?
H cube.
It will be capital order H cube. Now, you are committing capital order H square error in your Euler method, right? And you are committing capital order H cube error in your midpoint method. Which method will be better?
Midpoint method.
Midpoint method, because
Midpoint
if
method.
H approach H is small value, then H cube will be smaller than H square. H cube will be smaller than H square, whatever if the same H is there, right? So H cube is smaller, so you will commit less error for your midpoint method. You will commit less error for your midpoint method than your Euler method. Now is this clear?
Yes, sir.
Now
Yes, sir.
you can
It's
say
clear.
that midpoint method is better than your Euler method. So just you are using Euler method at one point, since you don't know other methods. Once you know the other methods, you can use the Euler method is called first order method because it is order I will define you. Basically, order is defined as if you divide truncation error by h. So what will be the order of th by h? That is called the order of the method. So for Euler method, since th is of order h square, capital order h square, if you divide by h, it will be capital order h. While if you see this midpoint method, th by h, with if you divide by h here, it will be capital order h square. So midpoint method is a second order method, and all these definitions I will show you in another slide. So and Euler method is a first order method. So midpoint method is better than that. Now, if you see this backward method, backward Euler method, this is also of order H method, or the first order method, or the local truncation error is capital order H square only, not H cube. Is that right? Is that right?
Yes, sir. Yes, sir.
Okay. So now the question which you have raised, that then what is the difference between the midpoint and the Euler method? Is that clear, part? Is that clear to you, to everybody? Is that clear to everybody?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Okay. So now you already have those problems, right? Those two problems. First one was y prime equal to t plus y, I think. Second is your y, u prime equal to minus 2x u square. So apply quickly the backward Euler. I have to tell separately because there are certain things involved in that. So you just apply this midpoint method to first problem. I'm showing that. I will just go back to the another slide. Again, the previous slide. Now I think it is visible to your screen. Whether the problem is visible to your screen?
Yes, sir. That is same t plus y problem. Na?
Exactly. So you apply midpoint method on this, and y1 you have already calculated here using your Euler method. Y1 is already calculated by Euler method. So use that y1 to calculate y2 for the midpoint method. Right? Take this image, h equal to 0.1, does not matter. And calculate y2 and tell me. Quickly tell me the value.
So 1.24.
Others also. Others also.
Sir, 1.24.
1.24.
The third person 1.24, second person 1.24. The first girl was told, she told
Sir,
something else.
1.24.
1.24. So that girl, you just correct it. Check it where you have done the mistake. So next values you can calculate. Now another thing, you just notice one thing. If you see the Euler's method, three different methods you have seen. One, you have seen Euler method. Second, you have seen the backward Euler method. Third, you have seen the midpoint method. In Euler method, it is an explicit method. At the same time, if you see yj plus 1 is calculated by using yj. On the left hand side, yj plus h times f of xj yj. Is that clear? Is that clear?
Yes,
now,
sir.
if you see your backward Euler, backward Euler yj plus 1 is calculated using your yj plus 1 and yj. but it is an implicit equation. You cannot calculate it explicitly, right? Third one is your, the method is your yj plus 1 equal to yj minus 1 and plus 2h times, what was that? 2h times
fxj
f of xj yj, right? So it requires two values, yj minus 1 and yj both. Is that clear? On the left hand side, you have to get the value of yj minus 1 and yj means the previous value and before that also, right? Is that clear?
Yes, sir.
Yes.
Okay, so means you require 2 points, right? If you see Euler method, it requires just 1 point. So the Euler method is called single step method. Midpoint method is called multi-step method, and both are Euler and this midpoint methods. Even though one is single step method, the other one is multi-step method, but both are explicit methods. Both are explicit methods. But your Euler method is, backward Euler method is implicit method. So 2-3 things we have seen. One, single step method, multi-step method. Second, explicit method and implicit methods. Is that clear? Is that clear?
Yes, sir.
So
Sir,
these differences, yes, tell me.
sir, but we get different values, and that in the Euler methods we get y2 is equals to 1.22, and but in midpoint method we get 1.24. So which is the exact, which is close to exact?
No, here you cannot get the exact. The another problem which you have y prime equal to minus 2x u square. There you have exact solution. You can compare with the exact solution.
Sir, both are explicit methods,
wait.
but
No, wait. Let me I have to answer your question also. No? Why it is coming? Why it is happening that you are getting, I mean, you can, whether you expect a better result or the what's result than your Euler here? First, you answer my question. Yes.
so can you repeat what you want to
Whether
say?
you expect a better result in your midpoint method or not.
Yes, sir, but I am confused,
Why?
sir.
No, wait. You just answer my questions. Your answer will be inside that. Now, you expect better. Why you expect better? I mean, there should be some reason. The reason I have already told. A reason I have already told that midpoint method is of capital order h square. Local truncation
Yes,
is
sir.
what? Capital order
H.
h square. While Euler method, you have local truncation of capital order h. Here it is h cube rather. If I say
In
local truncation in midpoint method. Midpoint. There it is in Euler method. You have only order h square. So you are committing less error for your midpoint method. So it is obvious that you should get better result here. You should get better result here.
Okay.
So
But
this you can visualize in the next problem because there you have the exact solution also. U prime equal to minus 2x u square. You know the exact solution is your ux equal to 1 upon 1 plus x square.
yeah. Okay.
So there you can put the value, you can see whether you are getting the closer value or it is going beyond that.
Okay, sir.
Right? So that's the reason I have told you how to find the exact solution or how to make a problem, and then once you know the exact solution, you can do as many as things with that problem, and you can compare the things once you know the exact solution. That's the reason I told that you should not depend on any other book or anybody. You can create your own problem. You can run that. You can, whatever the doubts come in your mind, do that. Sit down, change the step size, finer and finer. I will take words and words and then see what is happening. That is the numerical analysis. Numerical analysis, once you experience yourself, only then you can understand what is happening inside. Right? Is that clear now?
Yes, sir. Yes.
Any other query from anybody?
Sir,
Any other query?
sir, like, let's say we have divided our set into 10 parts, and we have to find y of 1 in 0 to 1, which is actually x of 10.
Okay.
Sir, if we use midpoint methods, we'll be able to reach in just 5 steps, whereas in Euler method, it will take 10 steps.
How will you reach at 5 steps?
Sir, x0, x2, then x2 is calculated for j equals 3, x4.
You can wait. You can compare the two methods if all the parameters are same. Means h equal to 0.1 if you are taking for Euler, you have to take the same for your midpoint method also.
Yes, sir. I'm taking same. Sir, I'm just saying I'm not calculating the odd j's.
Why you then how will you get that? If you are not calculating odd j, how will you see that you have just seen for your midpoint method y2 is calculated through y0 and y1 both. So if your y1 is not, similarly your next value you see y3 will be calculated through what?
y1.
Tell me. Y1 plus, and then you will get 2h f x2 y2. So it requires y2 also, it requires y1 also.
Okay, sir.
So
yes, sir,
you cannot skip any value. You cannot skip any value.
Yes, sir.
Right.
So like what we can say about the speed of both of these processes?
Everything will be told, actually, don't worry. That is your speed, that order which I have told you, na? That first order and second order. The local truncation error itself suggests that what is going to happen. That we are committing less error in midpoint method means it will go faster to the solution.
Okay,
right?
Okay,
And then Euler method is the first order method having more error, so it will go slower than that midpoint method.
Okay, sir.
Right?
Okay, sir.
So that's the reason. That's the reason I'm explaining each and everything. Anybody else has any query, you ask me.
Yes,
Without
sir.
any hesitation. Yes, ask me.
So can you please explain the meaning of implicit and explicit method?
You see yourself. Have you downloaded my notes?
Yes, sir.
Okay. So you see the backward, I have just explained also those things. Backward Euler method. First you see the Euler method. Euler method is what? Yj plus 1 equal to Yj. Tell me.
Yj plus 1 is Yj plus h times Fj plus the error term.
Fj means f of xj, yj. Right? Now,
yes.
At the stage of yj plus 1, yj is known to you? At the stage of yj plus 1, before you go to yj plus 1, before that yj is known to you? The previous value? Yes. Now, if you put on the right hand side, yj and f of xj yj is there, means only yj is there.
Yes, sir. Yes.
You can calculate this right hand side value.
Yes.
And you can get next value yj plus 1 for Euler method.
Right.
Okay. Now you go to the backward Euler method and see the right hand side. Right hand side is yj plus 1 equal to yj plus f of xj plus 1 yj plus 1.
Yes.
Right? On the right hand side also yj plus 1 is there, and you want to find out also yj plus 1, means your yj plus 1 is not known to you.
Yes.
right?
Yes. Yes.
Means you cannot get it explicitly. So the name
we have
comes
to
from
use
where?
Hudson method.
Name comes from there itself. So means it is not, you cannot calculate the value explicitly, means it is an implicit equation.
So we are applying
Right?
the Newton-Raphson method.
That is a different question. That's a different part.
Yeah. So it's
The point
directly we
is that
solve it.
how you see that it is a implicit or it is an implicit or it is an explicit method.
Yes, sir, understood.
This thing is clear? Okay,
Yes,
good.
sir, thank you.
Good. Any other fellow has any trouble? Any query? Anything of that kind? Anybody has any query? Don't hesitate. Ask me. As many as question you can ask. There is no trouble at all. No question? Shall I move further? Shall I move
Yes,
further?
sir.
Good. So you do the next problem using your midpoint method. I think the same problem was there. I think it is the values are also done here. If I remember it correctly, it is your midpoint method, right? Midpoint method I have already, Euler method I have already explained. For the second problem, u prime equal to minus 2x u square. You have calculated also u1. Yes or no? Hello?
Yes, sir.
Yes. So u1 value you know. Use that u1 value to calculate u2 using your midpoint method.
Sir, 0.84.
I don't know. I don't know. Possibly this is done through another method. Okay, you do one thing so that you can get the values here. You put y1 as 0.96. This is the calculated using another Taylor's method. So I will explain that later on. So you take u1 as 0.96. Then the values are like, or else you can put the value in ux equal to 1 upon 1 plus x square. See whether it is closer to that or not. There are two ways. So everybody just take u1 as 0.96.
Sir, the exact is coming as 0.86 and by this method it's 0.84.
Right. So you go to the next value. Go to the next value. Only one person has told to me. The others also, I expect that they should also tell. Anybody else has done the problem? I want the answer from other people also.
.86.
So verify using that one. I have already told the exact solution.
.852.
You have taken u1 as what?
U1 as 0.96.
Okay. With that you have got u2 as u2 as 0.85244 it is coming. It is shown on this slide itself. 0.85244. Everything, all the calculations are shown here.
I
For
got
you.
0.85254.
using 0.96 U1.
Yes, sir.
Just verify this. Check here also. Maybe there might be some mistake.
Up to 3 decimal places it is correct. After that it is 5-4.
Okay,
You got
so
4.
that part is there are two ways. Now one is truncate it or round it off. So there are two ways. Whatever it may be after that, it is truncated or it is rounded it off. So you can go for the next value. Shall I leave this as an exercise? Shall I leave this as an exercise? Yes, tell me.
Yes, sir. So the next is 0.6974.
No, it is it is U 0.6. It is 0.7274139. So you do it and check it. You can change the value of H. You can see that what is happening. Here it is 0.2 is taken. Take 0.1, see what is happening. Right? Unfortunately, this course does not have the lab work. But
So it's correct, correct.
So since you just listen me what I'm saying. This course does not have anyway. This semester, even if it would have been also, then also you cannot go to the lab anyway. So you know the programming languages. Some of the programming languages you must be knowing. You must have done in your first year one, right? Hello.
Yes, sir.
Yes.
Okay.
Yes,
So
sir.
you can write a simple program. This will be a very simple program. And then you can play with that. Means you change the value of H widely and then see what is happening. Reduce it to closer to 0. See what is happening. So if you write a program, you can understand in a better way. Right? So now I will tell one more thing. Because Taylor, it is basically part of that. So I will just close this. I'm not getting the answer from the other people. Only few people are talking to me. So it's not clear whether other people understand that or not. I'm continuously telling you without any hesitation, talk to me. Whatever is your query, does not matter. You ask me. I will explain that. You can ask as many as question you wish to. Okay, so I'm just closing this slide and I'm moving to the another one. Just few minutes, I will. It will take to come back.
Sir.
Yes, tell me.
Sir, in the previous problem, the y2 value we got from the exact as 0.84 and from this midpoint as 0.85. But in the Euler method, we got as 0.92. So like as the value is very different in the Euler method, so like we will use the Euler method or not?
No, I have already explained. If your Euler method is useful for several other things, but since this is the very first method, which is a very simple method, it is of order 1, means it is of the local truncation error is your capital order H square, right? So you first experience these things. Slowly we will see there will be plenty of methods which are in your course. Then there are others also, but at least you will see certain methods, don't worry. So Euler method is the first method and it is of the lowest order. If I say it has the local truncation error as capital order h square, means order of the method is just 1. Below that, it cannot happen anything other than that, right? So it is the lowest method, but it is quite useful in other words. Don't worry, right? So it is the very first day in one sense, I say. So you will see the plenty of methods, right? You see the next method, you see that. Okay. Hello. Okay. So don't worry. Next, you have done that Taylor expansion. I'm just simply writing the Taylor expansion. So utj plus 1 is your utj plus h u prime tj plus h square by 2 factorial u double prime plus h cube by 3 factorial u triple prime and so on. If we take up to this 1 by p factorial s to power p p at derivative of u at the tj plus 1, that local truncation error where you have truncated the series, and this is your s to power p plus 1 divided by p plus 1 factorial u p plus 1 tj plus theta h. Some of your friends has told this type of thing. Either you write xi or you write theta j, where theta h where theta is in your strictly between 0 and 1. All the things are same. All the things are same. There is no difference, right? This is your Taylor, simple Taylor expansion, and the local truncation error. If your yp plus 1 is bounded, then it will be of capital order s to power p plus 1, or the method of this Taylor method will be of order p, right? So this is called p order Taylor series method. This is called p order Taylor series method. Is that clear? Is that clear? Is that clear?
Sir, are you presenting something?
Oh, it is not yet presented. I'm sorry.
No.
wait. Okay, wait. I forgot to that. Now I think it is visible.
Yes, sir.
Yes, sir. Okay. Oh, sorry. That's the basic trouble sometimes. Okay. So the Taylor expansion of utj plus 1 is written here. Utj plus 1 equal to utj plus h u prime tj plus h square by 2 factorial u double prime tj and so on. The up to I have taken 1 by p factorial s to power p p at derivative of u at the point tj plus 1, where tj plus 1 is written as s to power p plus 1 divided by p plus 1 factorial up plus 1 means p plus 1 as derivative of u at the point tj plus theta h, where theta is in strictly in 0, 1. You know that Taylor expansion without any trouble, right? Everybody
Yes.
knows that. Yes. Now, so what is the local truncation error here? If p plus 1 derivative of u is bounded, it will be capital order s to power p plus 1, means the order of the method will be capital order s to power p 1 less, or pth derivative, pth order method means this is your Taylor's method of order p, right? So this is called the Taylor series method of order p. Very simple. Is that right? Is that right?
Yes, sir.
But it is not that simple. The reason behind that, you have this here, you are developing for u prime equal to fxy, or t is taken, so ftu. This is for u prime equal to ftu, right? Yes or no? Hello?
Yes, sir.
So means what? U prime is known. Up to u prime it is known. But you have to calculate u double prime, u triple prime, fourth derivative, fifth derivative, and so on. Is that right?
Yes, sir.
Yes,
Is that
sir.
right? So what will be u double prime means d by dt of
U prime.
u prime. but this is what? D by dt of f of t ut. This is function of two variable, right? Yes or no?
Yes, sir.
What will be the, you have read this chain rule. You have read this chain rule. So what is d by dt of ft? ftu, ftut?
First we
This
take
is
one
your
function as
del
constant,
f
then
by del
differentiate
t.
by.
Del f by del t. Yes, tell me. Del f by del t. Anybody can tell me? What is the d by dt of ftut? You have read or not? This is told to you. Yes or no? At least you answer yes or no. Yes. It is told to you or not?
Yes, so we know the chain rule.
Chain rule. So you have to do it here. So that is the required. So what will be that? Del by d by dt of u prime will be your ft del f by del t plus del f by del u, and since u is a function of t, so del u du by dt, so that is written as u prime. So this is ft plus fu u prime. This is your ft. U prime is again f. Since it is the differential equation is given as u prime equal to f, so this will be ft plus fu into f, and then you have to find out the next derivative d by dt of u double prime or u triple prime. That again you have to apply the chain rule. So do it yourself, right? All of you. So this is another exercise for you people that revise that chain rule which is told to you in your calculus, right? In your first year, right? And properly, so that you can calculate whenever it is required. So for this Taylor's method of order P, you require to calculate the P minus 1 derivative of U. So up to that, I mean, depending on which order, for example, if you require third order Taylor's method, then you have to calculate up to U double prime and so on and so forth. Is that right? Is that right?
Yes, sir.
Now the one question should have been asked from you people, that how many terms we should take for your own problem. Don't think that the things is given to you. For any problem you want to solve, how many terms you have to take and what should be the criteria. So just think over that. Just think over that. I have already projected the problem. Think over that and you may tell on the next run. That will be on next week, Wednesday. Right? So do all these things, all the exercises which I have told, and then we'll meet on next week, Wednesday, and I will proceed further. Right? Any query is there, you ask me. As far as today, it is more than enough. Any query? Anything from anybody? Anything from anybody?
Excuse me, sir.
Sure, ask me.
Sir, actually, solving any differential equation, ordinary differential equation means to get a equation like u as a f of x, such that it will satisfy the differential equation, right?
Okay.
So here we are getting the exact values of, means numerical
No, you are
values.
not
So
getting the, you are not getting the exact value. You are
no,
getting the
I'm saying sorry,
numerical
numerical values at that point, approximated numerical values.
numerical approximation of the solution at that point.
So from this point, using different
How will you get
methods
the continuous solution?
by using finer
This
edge.
no. What is your question? What is your question?
Actually, I was asking that here we are finding approximated numerical solution But
Fine.
solving any ordinary differential equation means getting the equation which is satisfying that ordinary differential equation.
Okay.
But here we are not getting that equation. So using that
Yeah, you will not get.
continue.
You are not going to get the continuous solution. To if it is possible to get the analytical solution, means the exact solution, then only you will get that exact solution. Now, possibly your question, which you are not able to frame it, is that whether these solutions are actually converging to that actual solution or not at that point. Is that? Hello? Hello? Your voice is not coming.
So same problem actually, network connection problem.
Okay, fine. Doesn't matter. Doesn't matter. I'm saying, did you hear me or not?
No, actually
Okay.
I had
No,
a
no,
call, so
I'm saying this thing, that possibly your question is that these numerical methods, whether they are converging to the exact solution or not, exact solution values or not. Possibly this is the thing coming in your mind.
yes.
Right? So that is the next part, the speed and the convergence. Right? When we say it is actually converging and when we say it is not converging. Right?
Okay.
So these things will come later. You have to wait a bit. Everything will come. Don't worry. The stability of the method, everything will come. Even though method is converging, it may not be stable. Means it is behaving in a different fashion with the different problems. So lot of concepts are there. Don't worry. So slowly it will come. Okay. That's the reason I said that you change the value of h. See what is happening. Change. So, but doing certain things you do manually. But if it is possible to write a program, it will be a very simple program. And then you can go to the computer. You can change your h 10 times, 15 times in few seconds, you will get the results. And then you can table those results, see what is happening, why it is happening, and you can ask the question to me also, from me also, that why said this is happening, why this is not happening, and so on and so forth. Right? So, but probably that will take a bit of time. But by hand, you cannot, there is a limit. You cannot do only this numerical analysis course. You are doing other courses also. So, but if you do write the program, then you can do it you can understand things in a better, right?
Yes, sir.
Yes. Okay, so it is up to you how much effort you are putting into that. It is very interesting course. Numerical analysis is very interesting course. There is a scope of doing new things every day. Things are happening also this way, because nobody can say ultimate that this is the best method and so on. There won't be any method, and that's the reason people are working continuously with this. And that's the reason it is interesting, and that's the reason it is. It helps in each and every branch of the mathematics, engineering, everywhere, whether it is a real life problem or whatever is that, right? The only thing you have to learn it properly, not keeping in mind that which grade we will get and so on and so forth. That will come automatically. If you learn it properly, grades will come automatically. Okay, so for today, if there is no further query, then I will close at this stage.
Sir, I have one query not related to the
ask me.
Sir, I have taken this course as additional but not receiving any mail. So I don't know which section I am in.
No, that I don't know. You have to talk to the Professor Murthy, because he is the coordinator. That's the
I have
reason I am
talked to
sending.
him, but he also said he has no idea. So it is really
I cannot do from my side anything. I can see only those students whose names are there in ERP.
Sir,
And that's the
in
reason.
ERP, my name is also there. I have also in my registration card the subject is there, but No mail
No,
is
that
coming.
you talk to the ERP people. If somebody, that's the reason I'm sending mails through ERP and to everybody. That's the reason I sent that code several times. Even after the last date of the registration also I have done that, right? So if somebody's name is there, then that fellow will get the mails.